Alright, so let's get started. Today we're going to be looking at what is a bit more known as functional programming. So right now we have been doing what is called imperative programming, where we do something and then we do something and then we do something, and maybe we do something in a loop and then we do something else and then we do something and then we're done. And that can work, no problem with that. But JavaScript provides quite a few functions to help us work with a larger amount of data a bit more easily, such as finding only certain values in an array, taking some sub-values of objects in an array, or combining all of these. The way they do this is that you have an array, you have functions, and then for these functions you can actually pass in functions. Yes, so you have functions and functions and a lot of functions. And once you think you have enough functions, they add a bit more functions. So let's just get started on that. Let me increase the size of this. Presentation mode. So if we just have our JavaScript here, let's say we have an array R that has a list of food. It has a burger, a pizza, and someone wanted a kebab from last time. Then we can say, all right, but I want to find all of those which name is only 5 characters long. I'm not sure I want that, but I'm picky with my food, so I only want the food that is spelled with exactly 5 characters. If we were to do that in the way we have learned so far, we would do something like this. So good food is equal to an array, and then we do for let I equal 0, I is less than r.length I plus, and then we do some food is equal to an array at I, and then if food.length is exactly equal to 5, then we can add it to good food. And then log out good food. That's how we would have done it traditionally, and this works. So let's just look at that. Make an index file here. Add in the JavaScript and then load it. So as you can see, we get those with exactly 5, pizza and kebab. But that's all well and good, and this can really work. But JavaScript, as mentioned, provides some easier way of doing this. Let's call it that. So if we comment out this, then we can actually do something like this. So const good food is equal to r, and then in this case we only want some of it, so we do filter. Filter says, all right, give me a function. This function accepts some sort of value, or provides a value for us. And then we should return either true or false if it should actually keep this value. So in our case, all right, let's just return true. Keep all of them for now. Then we can log out good food again, if I can spell. Let's do this one. As you can see now, then we just get everything. So that's good and well. But we only wanted the ones that actually had a length of 5. So we can say, all right, well, this is true if the length of value is equal to 5. And then we only get some of them. Or we could do it the other way around and say, no, I only want those that are not 5 because I'm really, really picky. So that is a way of being a bit more functional. As you can see, it's quite a couple of fewer lines, so it's 3 lines compared to 6, 7-ish. So that can really benefit them. Additionally, we have other mapping operators. So let's see that we have some lucky numbers. That will be 1, 2, 3, 4, and 5. And 5. And then I want these numbers squared. So that would be like 1 times 1. So I can go const square lucky numbers. And again, I create an array. We'll just do it the old-fashioned way this time. So I is less than lucky numbers dot length I plus plus, and then const number is equal to lucky number and I. And then we do new number is equal to number times number, and then we can add them to squared, and then we can write that out. And again, that's all good and well, but we also have operators on, or methods on maps, on arrays to help us with this. So if we do comment that out again, do squared lucky numbers, we have something called the map operator. So map says, I give you a value, you give me a new value instead of that value. So value, and then first we can just return the value, so doing nothing with it, and we should still get 1, 2, 3, 4, 5. But we wanted it squared, so we do value times value, and then we get that. But we can combine these. This is where it gets really, really, really powerful, is that I can actually do both a map and a filter. So I can actually, on this array I get back here, I can then do filter and then say, all right, function value, and I only want the odd numbers. So 1, 5, 1, 9, 25. And how do we do that? Well, an easy way is saying modulus. Have you learned about this percent operator, what it does? So it says give us the remainder, and if that is equal to 1, it's an odd number, and we should only get the odd numbers out. And we can continue. We can do a map on this one, and then we can value and say, all right, take the value and divide it by 2. And we can continue and continue and continue with these. So as you can see, the essential structure is that I pass in this function to the method, and then I can keep working with it. That's actually, like, I'd go with 70% of what we have to learn today, but doing these and using them is actually a bit more difficult. So we have some exercises for today all the way at the bottom here. All this code, you can just use that. That is not something you should worry about what it actually does unless you want to know. But we have some exercises here. So log out these 37 listings and log out. That's actually another method that I should probably show you. So we can also just do a normal for each on this. There's actually one called for each that again takes a function and value, and this we can just do whatever. We can log out the value if we want. If I can spell. As you can see, that writes them out, which is essentially equivalent to doing square. Same result. So the first exercise is use this code up here, create 37 listings. In this example they will create 20, I showed here, and then log out the size of every listing using these operators. So no imperative or procedural code, no doing this, only using map, filter, and for each.
No reduce.
The what?
Reduce.
We'll take reduce later because it's a bit more mind-bending than these are. So reduce is another function that says take all the values in an array and turn them into a single value. And you can actually implement map and filter and for each and everything using reduce. But it's also a bit more difficult to understand because you're kind of changing a continual value into an accumulator and such. It gets a bit more difficult. But start out with these, doing the exercises, try to get familiar with them. Just start with the first one for each. List it out in a simple way. We'll do it up here once you've done that. And then we'll try to go through well, how could we also do it? Why are we doing it this way and such? Okay, everybody up for that? Any questions to what we've written so far?
Yes, can you explain all of it again? That's one question.
Yes.
No general question.
Yeah, but
But that's not a question, it's a statement.
No, I'm asking, can you?
Yes. Then it's a
yes.
question. And she's the only lady in the class, so.
Yeah, so I have to be nice to her.
You just have one answer, actually. That's a yes.
Yes, I cannot take any no.
Yeah.
No, but on array, there's all these methods. You have tried working with push that adds a new value to the array. You have tried working with shift, for example, that removes the first one, pop that removes the last. But they also provide other functions. So in this case, they provide an example, a filter function that says, all right, for this filter function, we need to give it another function.
Okay.
And this function is then called for every value in the array. And then if it returns true, we will keep that value. If it returns false, we throw it away.
Okay.
Don't care about it. And then we get a new array back with the new values. The old array still has all the values that were in there. They have not changed. Only the values in the new array. But start out with the for each. Try just doing simple like we did up here. Try something very, very simple like this. Just try writing it out, getting it in your fingers. Then we can look at it.
Okay.
And then you can try to explain to me what is going on. Because that's a really good, yes, I won't judge you. That's a really good way of trying to see, so where is your knowledge then falling off? Where is it becoming a problem? If you try to explain to me what's going on, then I can try to fill out the holes.
Okay.
Yes.